So chapter 6 is going to be going back to radicals again. So I know we did a little bit of work with some square roots in the past, but we're going to go back to square roots again. We're going to talk about some other roots as well, and then solving some equations with radicals. So when we raise a number to the second power, we say that we have squared the number. So sometimes we may need to find a number that was squared. So this is what we call the process of finding a square root. So what we mean by this is that if I look at, say, 25, well, I have two numbers that I can square that give me 25. So if I take 5 and I square it, well, 5 times 5 will be 25. But I also know that -5, if I square it, will also be 25 if I square the negative. So the process of going backwards and finding these numbers is finding the square root. So I would say the square roots of 25 are -5 or 5. So this is what we're talking about this finding your square roots. Like I said, we've done some of this before. So more of a definition, a number C is a square root of A if C squared equals A. As we saw before, so we were talking about 25. So 5 is a square root of 25 because if I take 5 and I square it, I get 25 back. And like we said, the same thing happens for -5 as well. So properties of square roots. So when we talk about square roots, we had two roots. We said that 5 or -5 would work, because I can go back and I can change this and go, well, -5 is the square root of 25 because -5 squared is also 25. So every positive real number is going to have two real number square roots. You are going to have a positive, what we call principal root, and a negative root. So what we have here is that for 25, we have the principal root, which is going to be 5, and then we have the negative root, which is going to be -5. Okay, so like I said, this applies to every positive real number. So this has to be a positive real number. However, if we have 0, the number 0 has only one square root itself, because if I take 0 and I square it, I get 0 back. Therefore, the square root of 0 would be 0. So 0 only has one root. And negative numbers do not have any real number square roots. So if we go and we talk about negative numbers, if we have a -25, there is going to be no square root in the real numbers. So remember, I'm talking about real number square root. So there's no square root in the real numbers. We know in the complex numbers there are. It was part of the reason we have complex numbers is because we didn't have a square root for this. So just as a kind of reminder, the reason this doesn't work is because I have to square a number and make it -25. Well, -5 squared is +25, and 5 squared is +25. So there's nothing I can square that's going to give me -25 in the real numbers. Oops, forgot my real numbers here. Okay, so like I said, for example, just again, 16 has -4 and 4 as its square roots because -4 squared is 16, +4 squared is 16. -9 does not have any real number square roots because there is no number C for which C squared equals -9. Okay, so going through this, we want to find the square roots of different numbers. So one of the things that might make this easier is every time you're trying to find a root, so we're not going to look at just square roots, we'll look at cube roots, fourth roots, and fifth roots. It's good to kind of go through and make a list of all the squares. So if I take 2 and square it, I get 4. If I take 3 and square it, I get 9. If I take 4 and square it, I get 16. If I take 5 and that is squared, that is going to be 25. I don't know what I was trying to write there. I think I was up to 6. 6 squared is going to be 36. 7 squared will be 49, which is the one I need. 8 squared is going to be 64. And 9 squared will be 81. 10 squared, that's 100. So kind of keeping a list of squares or memorizing it will help you with some of this. So what we have here is that if I take 7 and I square it, I get 49. But that also means because we always have two roots, a positive and a negative root. So also, if I take -7 and I square it, I would also get positive 49. So my roots are plus and minus 7. Okay, so just take a moment here and just figure out the roots of 25, 100, -16, and 0. So 25 we've done once already. So 25, well, we see that's from comes from 5 squared. So its roots are going to be and remember, we're going to be in the real numbers. So we're looking for real number roots. So my square roots will end up being, we know 5 is one of them, and that means -5 has to be the other. For B, we're looking for square roots again. Well, here's 100, and 100 comes from 10 squared, so we know 10 is one of the roots, but that also means -10 is the other root. -16, this one we would say has no real number roots. Because there's nothing I can square that's going to give me -16. Because if I take -4 and I square it, I get positive 16. And if I take 4 and I square it, I'm going to get 16. And 0 just has one square root. And that's always just going to be 0. All right, so the principal square root is a non-negative number that is it oh, sorry. The principal square root of a non-negative number is a non-negative square root. So meaning it can be 0, but it can't be negative. So it could be positive numbers or 0. So that's all we mean by non-negative. Positive numbers or 0. So the principal root, so 0 has a principal root, it just has 0. So that's going to be included here. The symbol that we see when we see just the square root of a number, this is indicating a principal root, so we only want the positive root. If I, however, want that negative root, then I'm going to say negative square root of a to designate the negative root. So if I did the square root of 9, like I said, we know that -3 squared is 9. We know that positive 3 squared is 9. What I'm looking for here is just the principal root, so I'm just going to have the positive 3. Here, what I'm asking for, if I say I want the negative root, then I'm going to say negative square root of 9. So that one's telling me I want the -3. So in essence, all we're really saying here is that if I do a square root of a number, what I expect to come out to be positive. And if I want the negative root, then I have to put a negative out front. So this is just sort of like a basic rule because we want to make sure that when we do square roots, that we're not ending up with two solutions. Because we're trying to set something up to be a function. So if 9 goes in, we're not seeing the square root of 9 as -3 and 3. We're going to say the square root of 9 is just 3. So we're forcing this into a function. Okay, so just as a reminder, we had talked about this before, but because square roots are essentially exponents, So at one point we said like the square root of a is just really the same as a over the power of 1/2. This means that any root that we use, if we do an nth root of a, then that is the same as saying a to 1 over n. So rules of exponents are going to apply for roots. So one of our rules with exponents was if I had a product of two numbers and I raise it to a power, then that power distributes across the two numbers, across the product. If I have a quotient and I raise it to a power, then that power distributes across the quotient. So the same thing applies here with square roots. The square root of a times b is equal to the square root of a times the square root of b. And the square root of a over b is the square root of a over the square root of b. So we're not going to use necessarily all of these right away, but we are going to use them. So we want to simplify each of the following. So the square root of 81 would just be, well, 9 squared is going to give me 81. Like I said, we also know it's negative 9 squared gives me 81. But remember, we're only taking principal roots. So we're going to only have 9. If I have negative square root of 16 over 81, well, we keep the negative out front, but this the square root can break up and we have square root of 16 over square root of 81. And of course, 4 squared gives me 16. And we're only interested in the positive root, not the negative root. So even though this is true, we're not interested in that, just the positive roots. So we'll have negative, and then the square root of 16 will be just 4, and square root of 81 will just be 9. So that negative out front is giving me the negative root of 4 over 9. Okay, so take a moment here and pause and work on these ones. The one was kind of a trick here, but it's deciding, like, am I doing principal root? Am I doing negative root? So just finding our different roots. All right, so we know that 4 squared is going to give me 16. So what we're asking for here is just the positive root. So we're just going to have 4. Here, we're going to have negative, and then square root of 16 is also 4, so that's negative 4. Here, we know that 10 squared is 100, and we know that 7 squared is 49. So we can break this up into the square root of 100 over the square root of 49. So that's just going to be a square root of 100. Positive root is just 10. Square root of 49, positive root is just 7. So it's 10 over 7. And then here, well, we're doing the square root of a negative number. We can't do square roots of negative numbers. This one has no real number solution. Or we can say it's undefined in the real numbers. So we're going to use a calculator to approximate the following here. Okay. So what we can use is Desmos. So just as a reminder, in Desmos, we have the square root function here. So I need the square root of 13. So we're going to do that square root, put in 13. And what we see is that for a, the square root of 13, oops, put my equals in the wrong spot. The square root of 13 is going to be approximately, and we're just getting approximations right now, 3.606. So I'm just rounding 3 places. So sometimes with certain problems, we just leave square roots as square roots because this is an exact answer, that's square root of 13, where this is an approximation. We also want the square root of 527. So we hit that square root and we put in 527. So square root of 527 is going to be 956. We round to 3 decimal places. Like I said, that's an approximation, so we need to make a little approximation symbol. And then for C, so C has a more complex real number. So remember, there's a negative out front, and we want the square root of 8,423.5. We hit negative square root of 8,423.5. So negative square root of 8,423.5. It's just going to be negative. Remember, we're approximating again because we're approximating the square root of the calculator. 81.7. Well, it's going to be 780 after I round it. So if I try to round here, this rounds up to a 10, so that rounds that up to an 8. And I realize this is probably just review for you, but for both of these, we just wanted to find the square root of the following numbers. So we're going to find the approximation. So take a moment with your calculator and find those. Okay, so remember, we're not talking about simplifying. We could simplify like this one here. This one we can't simplify, but we can simplify square root of 8, because if you remember, that's just 4 times 2, which is just the square root of 4 times the square root of 2, which is just 2 square root of 2. So this would be my exact simplified answer. But my approximate one, oops, if I did square root of 8, is going to be approximately 2.828. And this one here, I just did negative and I just put in square root and I did 3/5 on my calculator. Or you can do this as negative a square root of 0.6. Oops. If that's easier to put in, but either way, you're end up going to have negative 0.775. Okay, so like a quick review of what we were doing with square roots in the past.